Hi guys, can you hear us and see us? Please let us know how is it on your side. We have a special guest today on the stream with who we are going to dive into Vulkan-based game engine. And we have Łukasz. Please introduce yourself.
Hello, my name is Łukasz, originally from Poland, living in Switzerland. And, after my day work, I'm handling the podcast named Game Engineering Podcast, and I interview people. For everyone who is interested in technical discussions, they can go to Game Engineering Podcast on pretty much any platform under the sun that handles long form video and audio. You can find me, including weird sources like X on like long form video directly on X, because the X has a desktop app you can have on your TV and watch stuff like that. So that's me. And I'm also like hosted by Maria. Hello.
Hello, and also you can find the links to Łukasz YouTube channel under the description for this stream. And please, guys, as always, let us know in the chat how you hear us and if everything is all right on your side, so we can fix it before we went somewhere further. Yeah.
So there are some voices that my voice is a bit quiet.
Oh, okay. Yeah, I see. I will gain it. Well, let's try it like that. Will it be better? Łukasz, say something.
1, 2, 3, 1, 2, 3. The weather is today great, sunny.
Okay. Then I guess we can start, and maybe Łukasz, if you want to say something about what we are going to do today, or I can just.
Yes, so we're gonna dive into Vulkan API. I have never interacted with Vulkan directly, and let's start with a bit of like a poll. There is a poll right on YouTube. You can vote. What is your graphics programming experience? And this would be for us quite interesting source in terms of how deep can we go into technical details, explaining some of the things. Because like Vulkan is not the easiest API, and it would be helpful for everybody to understand the graphics basics first. So let's see. In terms of a poll, we have graphics programming experience. 50% of the votes are none, which is 0, and 30%, so 1/3, is less than a year. And there are a couple of people joining us for more than a year, and very few don't want to talk about their graphics programming experience. That's nice. Okay, so maybe we can start with a bit of like overview of graphics programming.
Yeah.
Let me do my understanding, and you will correct me.
Yep, for sure.
If I get something wrong. So graphics programming is the underlying rendering component of a game engine. So your computer has graphics API, and you can use it to talk to graphics card in general. And the whole point is to render things on screen. And especially when going from 3D to 2D, you need to have some sort of mathematical transformation to make it happen. So whole goal of this rendering pipeline is to get from 3D model that is expressed as 3D points in 3D space, to a 2D screen with a rendered character, for example, like The Witcher from The Witcher games, which I love because I'm Polish, and The Witcher series is Polish. At least has the Polish roots.
I love it. I love it. I read books, I played games, just one of my like favorite series, I guess, universe. Really good.
Yeah. So we'll start, generally speaking, the rendering pipeline starts from a bunch of 3D points that are organized usually in 3D triangles, like triangles in
Usually.
3D space. Say again?
Usually, yes.
Usually, yeah. Not always, but usually. And then through a series of transformations, we get from the 3D model to 2D image that can be rendered on the monitor. And there are a couple of stages of this pipeline. You can think of it like it's called as a rendering pipeline because it has stages. So we go from one to another, and usually the output of one stage is the input to the other next stage. And to grossly oversimplify, let's say that you have shaders, which are programs you can run directly on GPU, and you have as a first stage a vertex shader, and it will run for each vertex, and you can do all sorts of transformation within this vertex. Then you have the process called rasterization. So from 3D triangle, you are mapping this onto 2D pixels and what space this triangle is occupying. And then you have a fragment shader. And for each pixel, let's say pixel is a fragment. It's a simplification. I forget why it's different, but let's say pixel and fragment is the same thing. What's the difference? Do you remember?
No, I'm just always thinking about fragments as about pixel elements.
Yeah. So I think it's like a pixel plus some data, but whatever. It's basically the same. So for each pixel, you can render, and the output of the fragment shader is a color. So color that you need to render your pixel with. So we go from 3D points through a couple of shaders, rasterization, fragment shader, and then you have your image on the screen. And this is like the most basic thing. And there are situations and components you can do like more advanced stuff. For example, if you want to do like blur or all sorts of post-processing effects on the entire frame that you already have rendered, you can do this. But generally speaking, that's the goal of rendering pipeline, to go from 3D models through all sorts of custom logic using GPU, graphics card as a hardware, to 2D screen that is usually beautiful in terms of new modern 3D games.
And very complex.
Did I get this right?
Yes, of course. I guess it is a very good introduction to what the graphics pipeline is. Maybe, I'm not sure if you want to add something here or...
No, I think that's it.
Okay, I just like from my side would want to introduce the idea of game engines itself a bit before we go further. And because like probably since of the, I don't know what's the poll results are, but lots of people have no experience with this kind of programming, so maybe it might be interesting for them to understand what is actually here the everything is about. Yeah. And like as Łukasz said, we are working with a representation of 3D objects into 2D screen space, and it is the basic goal of the graphics engine part. But the whole idea of game engine is more complex because we have to create a software that will handle lots of small things like decorations that will go and be useful for programmers to build a whole game on it. So it should be also an audio handling, physics handling, asset resource management, and all that, like lots of stuffs. And like graphics engine is one of the important parts, but it's not like the whole part of the game engine itself. So yeah, it's just basically one huge software that helps us to create a game on it according to some provided rules and I don't know, specific functionality. Yes, because we can have a for example, the dedicated engine for platformer games only, or we can have a dedicated engine for first-person shooters, and we will concentrate on this idea and improve such mechanics. So yeah, that's the idea. I have no dedication on my engine. I'm just trying to learn Vulkan. This is my dedication here.
Yeah, so for example, the Unreal, Unity, and Godot, they are now universal game engines, even though Unreal started as actually a like FPS engine, but still you can make, at least in principle, any type of game with these engines. But there are more niche game engines like Adventure Game Studio, where it's not really feasible to do FPS there. You have like, for point and click adventure games, you have already abstractions that are like items and locations. So you have like very dedicated tool to do exactly the type of game you want to do. For this engine called Anthrax-AI engine, it's more of a universal game engine with lots of universal abstractions. So you can kind of build anything with it.
Very, very beautiful thoughts.
If you're really persistent and you will dig through the code, you can probably build anything.
Like, yeah, because now it's just a empty canvas for now.
Yeah, yeah. So for this part, by the way, the source code is available,
Yes,
right?
yes, it's also a GitHub link for the repositories and the description to this stream.
Yeah, and for this stream, we will focus on the Vulkan and rendering aspects. As you said, like rendering is just a piece of game engine. Obviously, it's a big one, but you need all sorts of like game engine abstractions to make things happen. And we will not focus on these. They are like in the, let's say, other folders. We'll now focus more on the Vulkan side and Vulkan API specifically.
Mm-hmm. And when I was preparing to this stream, I like it is when person will Google about Vulkan API, I guess it's not hard to understand that it's very complex thing. And when I was preparing to this stream, I realized how actually complex it is, and I'm super afraid that when I will talk about things, it will in the end sounds like a mixed salad. But I will try to make it as more like, I don't know, high level, or just like cover it not without like any deep maybe super deep technical things, because yeah, just like it's not possible to cover in 2.5 hours. So yeah, I will be happy if we will just go through this during this stream. Maybe we won't, who knows. Whatever.
And Vulkan is a graphics API that is coming from Kronos Group, who made OpenGL as well. And it's like a next generation. It's sometimes called modern graphics API, like DirectX 12.
Yes.
And the idea is that previous generations, like OpenGL or older versions of DirectX, they gave much less programming power over the already established abstractions and pipelines to developers. So now it's much more doable to do all sorts of wacky stuff with this API, but this also comes with complexity cost. And Vulkan, coming from Kronos Group, is the API that is attempting to abstract over all sorts of things that GPU manufacturers came up with, which makes it a difficult API in terms of like, it's trying to cover every possible use case, right? If you have a metal API, so from Apple, they can just cover what they have in their closed walled garden system for Apple devices. In this case, Vulkan needs to abstract over everything, and it results in a difficult, generally speaking, sometimes frowned upon API. I was I was afraid of looking at Vulkan code for a long time. So I'm really happy for the opportunity to dive in with somebody who's experienced.
Yeah, I'm still learning, but some experience I have because I'm doing this almost every week, like every day and every week on live stream. And again, a very, very thank you for joining the stream today. I am really glad to have such a guest on my small YouTube channel.
Okay. Shall we start then?
I was wondering whether maybe you want to see what engine can do now. Maybe it's just like a
Yes,
small
yes.
presentation, and then we will go through the code because maybe it will make it things a bit more. I don't know. Maybe who knows. Anyway, let's start. I will just run it and check that you can see everything. Yeah, you can see it. I have like a small intro part. Because my background sits in the demo scene. It's an old programming community which were using retro PC to do some graphics, visual effects, and yeah, I just was inspired by this, and I wanted to have something like similar. And when we want to move further, we need to press escape, and we will have a very, very simple editor window, and we need to select scenes available from the scene folder that I can show later. And I will just, for example, run the scene with the textures. Is everything fine still? You can see here everything,
Yep.
yes? Okay. It is just test scene with two textures, and it's just to test whether I can still render simple 2D objects. And I can go to the scene tab where I will have a name and objects available there, and see the position, the texture which is attached, the fragment vertex shaders, which basically builds a material for such object. And now we are also able to, when we selected it, we are also able to change the texture and also update the object. And then we will, oh, sometimes happens segmentation fault. not everything is working anyway. Yes, still it is all in progress, and things like that can happen anyway. Where I ended up, you can change textures available from the texture asset folder, but you can see it now. Now you will be able to, I guess, yes. And yeah, that's basically what you can do on this level. And
maybe I can chime in. So game engines usually have a couple of abstractions that you might know if you ever used Unity or like Godot. For example, materials. Material is the de facto a shader with a couple of parameters that you can tweak. And also like you have some sort of objects that usually have some sort of position. Here you already have a texture that you can render on them. So these are like conventions that you kind of have to establish once you have, if you want to have something that you can show to someone. So like I was using other engines, so I recognize these abstractions. For everybody who is like never seen such things, these are the things that you kind of end up doing, generally speaking, in the 3D engine that you want to do. So for example, like materials and some sort of object abstraction, you won't get away with not doing that. So like we're skipping over the details there, with like not necessarily diving into like how they're done, but just showcasing what's possible.
Yep. Thanks for the such like comment, because yeah, I forgot that someone don't know that. And yeah, of course. And then to run more interesting use case is of course seen with the 3D objects. And when it is here, I was also like playing with the textures, so they might be very weird for now, because I just like 2 weeks ago I added a functionality to be able to change the textures. So, and basically when you are in play mode, you can also select an object and move it. And it is also work in progress. I worked on this like beautiful outline thing, and it wasn't very easy to do for me. And still you can see like some artifacts on the top of the screen that appears, but it is still very, very, very lovely work for me. I really like how it looks, and I guess it has very big potential, especially when the object overlaps. I just love it.
I cannot not ask how the outline is done.
I will show it maybe in RenderDoc better, but
Okay.
if to describe it very fast, each time when I have a selected object, I am running it I'm running it after the rendering. I'm running the selected object in additional rendering module that renders only. It leads the mesh with one color. The mask, it's called masking. So basically, I have a texture with these like shapes of monkey lit with one red color. Yes. And then I am passing this mask texture to the outline shader when I am checking the differences between colors on the edges, and this helps me to identify the this like edge shape and cover it with the color. Yes, so basically I have a red monkey and I'm checking how far it is from the edge. Yes.
Okay. So
yeah.
we're doing edge detection
Yes.
for the
Yes. Using the
with
mask.
some sort of mask. Okay.
Yeah.
Okay.
But I think that it looks very cool, and it has very big potential to be a very, very nice thing. Yes. So
Nice.
yeah, and like the biggest, of course, fight for me is creating this Gizmo system. There, of course, like exist already frameworks and libraries for such editor-related stuff. Yes. But I've decided to understand how it works with like just by myself, and that's the reason why it is a bit laggy sometimes and not perfect, basically. But
And
I'm
gizmos, so gizmos are these like arrows, but it
yes,
can be
yes,
also
yes. It is.
other
It is, I guess.
other stuff.
Yeah, I really want to believe that it is like professional term that I didn't made this
Oh yeah, I
word.
think so.
Yes, and
I think so.
yeah, and like yeah, just the thing that is working there. And I guess again we can select the objects. We can see the type of the object because I'm trying to somehow define the objects in like whether it is sprite or NPC. I just decided to make such names to simplify things, and we can like select monkey again, change the texture, and same for cube, same for animated object, and yeah. So basically, this is what we can do. I also have an engine real-time shader update, so when we change the shader code, we can just press the update shader button, and then we will have the reloaded pipeline attached.
Nice.
Yeah, to the
Nice.
materials. Yeah, it was one of the latest things I done during the months, and it is very, very useful, especially when I was working on my intro. And I was frequently changing the shader code, and it starts to be very annoying to all the time close the program, rebuild it, and run again. So I made it like this. And Vulkan SDK provides great tools for that. Yeah, so I was just using library from there to compile shader. And also I have an audio tab, and you can like select from available sounds and play it. You can stop it and stuff like that. I was also having like fun with that. And I have a debug tab that like you are able to, for example, if you don't want to render 3D grid, you can disable rendering. You can also check the bones weight. It is like very useful for animation, skeletal animation programming. Yes, you like each of the bones you have on the animated object, it has a weight to each vertices, and this like debug thing allows me to see which vertices are being affected by the bones in this animation. So I can see, for example, whether transformations from the animation were applied correctly. Does it make sense?
Yeah.
Yes?
Yeah.
And it is very cool, and like when I was doing this for the very first time, it was very, 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 very useful to understand which errors I might had when I was calculating the transformations. Yeah, so this is my engine.
And shout out to dear IMGUI library.
UI, you mean?
Yeah.
Yes,
yeah,
it is IMGUI library. It is open source, very, very light and simple UI library that I guess is probably industry standard, I would say. Like, I mean, industry standard in custom engine development.
Yeah.
Yeah, people use IMGUI all the time. Yeah, stuff like that. So if you have some other questions, or I can close it and we will go further.
Yeah, I think we can start with Vulkan then.
Okay. Let me see. OBS seems to be all right. Okay, maybe few moments to look in the chat. I don't know. What do you think?
Yeah. Are there any
I just will
questions
check
so far?
if there is something. Just for your information, people without graphics programming experience are like winning for now.
Yes, 54%, so
Yeah.
over half has no graphics programming experience. So it will be a rough ride, but we'll see. Have you been in Sponza Palace for real life?
Have I what?
Have you been in Sponza Palace in real life?
No, never. What is that?
There's this chapel that is very much often used for like 3D rendering.
Yeah. No, I never was there. And you?
No, never been there. This was one of the questions from the chat.
I see an interesting question that person have experience with OpenGL. Is there a reason for moving to Vulkan? I guess one of the biggest reason is that OpenGL last update was in 2017, and it is pretty like long time ago in terms of GPU evolutions and all that. And OpenGL is just, in my opinion, is out of dated API that doesn't allow us to use GPU functionality on maximum. Yes, and I guess that it is already being moved from the actual gaming industry, and it is not being in use. And if you want to continue a journey as engine developer, the DirectX 12, either Vulkan is a better option, I guess, to be at least like updated to the market, if I can say so.
Yeah, OpenGL, like depending whether you're professional or hobbyist. Like if you're a hobbyist, then it's super fine to continue with OpenGL. But if you want to remain a professional developer and grow in the industry, then there's no way to escape either Vulkan or DirectX 12.
For sure. Yeah, like hobby is a different, of course, example. And yeah, I assume for hobby you can use whatever you want, and just like not even a question. Okay, then so we are a bit on the schedule. Vulkan.
So maybe yes, just right before we dive in. So the structure is usually that there is some initialization in the beginning, and then there is some loop that is doing things every frame, right? And this is pretty much like every program really works this way, like web servers, games, anything you can imagine that are not like scripts with like starting from point A and then ending point B. It's just that you have a loop that is going to do something every frame, every cycle, but beforehand you have some sort of initialization. And probably in the beginning we'll look at the initialization code for the Vulkan API, and then we'll see, like, try to break down some of the like building blocks that are there.
Mm-hmm. Yes, so as Łukasz said, I have the Vulkan initialization part, which is called on the beginning of the life cycle of my engine software program that I'm writing. And basically, it is applicable to a very simple Vulkan renderer, I guess. So it won't be something like very, very special. And essentially, like, these initialization steps for Vulkan are pretty like much the same, but of course, when we talk about programming, you can always be creative and do things other way. But yeah, anyway, you have like some sort of steps that you have to do in order to make Vulkan backend running. And first, I guess we will just go through this function and look into the functions that are being called, just to simplify the interaction with this topic, I guess. Yes.
Yep.
So first, I am calling function create vk instance, which is creating Vulkan instance. And Vulkan instance is an important part of the application, which acts as a bridge between our application and Vulkan drivers. So it is a global handle that is very important. Without that, we can't do any other further steps. And like, I won't comment every line of code because it will make this stream very overwhelmed. But the important thing that you have to know is just that you can provide some your application name to such object. You can provide, which is very important, Vulkan API version, because there are different of them, and for example, older one doesn't allow us to use some newer functionality, obviously. So that's important thing to add there, so Vulkan knows with which version we are working of the API. Yeah, so Łukasz, just if you will have some questions and stuff, just feel free to stop me, because I will just go after step by step and talk about things.
Okay. So yeah, I understand that this is like a beginning thing that before any other calls to the API will be issued, you need to have sort of established the protocol that you're gonna talk with. So for example, the version, and then a couple of names for the window, and like engine name, application name, I can see, and some other stuff. So yeah, I kind of expect this to happen, like some sort of init code for the everything else to come next.
Yes, and also very important part happens here, that we are enabling desired instance extensions, which I will cover a bit later, and also layers that we want to enable during the whole our Vulkan application will be alive, let's say. And as mentioned earlier, Vulkan is a very explicit API, so you have to literally define almost every small detail that you want to from Vulkan to get, yes, for your application. And instance extension is very important part, because in this part we are telling Vulkan that we are going to work with windowable application, with application that has a window to output something. Yes?
Okay.
Yeah,
Okay.
and if I will go here and see what it is, what type it is, we can see three important variables here. And the first extension is a surface, which is very important to Vulkan to know that we are going to work with the window managing API. When we want to create a window, we have to ask for some specific platform-specific library to create this window for us. In Windows, it is Windows API. In Linux, it is, for example, XCB library, which is being defined also at the beginning of our engine living cycle. Yes, we need to create a window, and Vulkan needs to know about this window. Does it make sense now? I'm
Yeah.
wondering.
So you're defining like an extension
Yes.
for Vulkan that will come with the utilities for a window creation for a given platform.
Yes, so Vulkan will know that it is going to be one of its functionality, because Vulkan driver is a huge driver. It has lots of things, and we need to specifically enable one of them if we want, for example, this kind of functionality have there. And also define the platform. You can see that here I am connecting a Linux surface extension, and here if we are working on Windows, I will try to connect to the Windows platform thing. Yeah.
Are we gonna do like Windows 2 every time we're gonna mention Windows, or like, because you're on Linux, so I'm assuming you're like against Windows as a platform.
Yeah, like I don't like it, but people work on it, I guess, much often than on Linux, even though now I think things are changing for like Linux gaming situation, but still like
Yeah.
Generally people use Windows, and I want people to be able to see the engine on Windows too, so like I'm trying
Yeah.
to handle it to be cross-platform, but it is sometimes annoying and hard, because it is not always something that I want to do on my free time to like solve some Windows bugs or stuff like that.
Yeah. Yeah. And for everybody who's coming from like web dev world, they probably think that like everyone is using either Linux or Mac. Like nobody's using Windows for development. And then for everybody who is like game development, like especially like AAA, they feel like nobody's using Linux. Everybody's using Windows for development. Like you might be one of the only people who have like NeoVim, Linux, and doing Vulkan and game engine from scratch. Like this combination is like super rare.
Well, I'm not sure. Like I guess so. But when I started to work at my company 2 years ago, it was really like a dream, because we are supporting Windows and Linux, and like maybe not half, but big part of my company, they are using Linux on their daily basis. And when I
Okay.
came there, it influenced me so much, and now I just can't imagine my life differently. Like it is very cool that just historically it ended up running the game on two platforms. So yeah, but it is rare. Of
Nice.
course, it's rare.
Nice. What are layers? What are
Yeah.
Vulkan layers?
Yeah, then we will see the back of this creation of instance. We are also enabling the layers, and layers is kind of like if extensions is something that already exists in Vulkan driver, yeah. So and we have just to enable some features, let's say, from the driver. Then layers is something that is put in between of your application and Vulkan driver, and it is used to analyze and modify the behavior of your Vulkan application without modifying the driver itself. So layer is something that any vendor, any third party like software can create its own layer and provide to the Vulkan application, and it will like handle things according to the rules. And let's say usually it is done for profiling and debugging, and I am enabling validation layer, which was provided by Kronos, which helps us to debug Vulkan API calls, and if we made a mistake, it will analyze it and return the debug information, like error information or warning information about that, because raw Vulkan itself doesn't do any debugging for you. And for example, just to extend this talk, NVIDIA or AMD can have their own layers that will somehow analyze and debug some specific NVIDIA or AMD related stuff, yes, for Vulkan. It is also what can be enabled, or for RenderDoc, or for any other things that have their layers. Does it make sense?
Yeah. 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 Yeah.
Yeah? Okay. So basically, that is what is happening here, and we are simply telling Vulkan that we want to render into window, and we want it also to check whether our code is valid and if we are not making any mistakes.
Yes.
Yeah.
Yes. Awesome.
Okay, so the other step is also very, very, very important because I'm going to create device-specific information. And if we will go to look at there, it's also covering the step of the creation of the surface, which is a Vulkan platform-specific object, as I already mentioned. But here we just are explicitly creating it and providing the descriptors or handlers from the window manager API that we are using to create our window. So Vulkan can use it under the hood when he will want to present the final rendered image, yes, to this surface. So surface is not something that is responsible for rendering. It is only like the path.
Bridge.
Sorry?
Like a bridge.
Yes, like a bridge and something that helps Vulkan to identify where to present the final image. Yeah. Okay. And yes, so after when we are back to the device initialization steps, we have two important parts of the creation of physical device and logical device. And I don't know, I should start from the difference between them or just go step by step what's happening. I don't know how it will be more.
I don't even know in what way this is a device. So
Okay.
It's just what's a device in this context?
Okay, so physical device is basically a representation of our GPU. Vulkan is able to go through available GPU connections and see what entries are. So for example, if we have setup of the PC where we have integrated and dedicated GPU, Vulkan will catch it. And for example, according to some verification statements, conditions, it will choose the most suitable one. So for example, if I have very low-end integrated GPU and high-end dedicated one, Vulkan will compare their capabilities and return the most suitable for us. Yeah.
Okay. That's interesting.
Yeah, so it's basically the raw representation of our GPU. And when we will select the desired one, we want to create a logical device from it because we don't have any direct access of the GPU. And physical device, it has only hardware detail information. So for example, what type it is, what video memory size is, for example, what features it has. For example, can this GPU be used to ray tracing? Yes. Does it has this course, for example? I don't know, just an example. Yeah. And after we have this physical device, we can use this information to create a logical one, which will help us to interact with the GPU and ask it, for example, can you please allocate this amount of memory because we want to put there a texture, or can you do now compute shader for me because I want to do ray tracing. So it is basically also a bridge, another one. It is very, I guess, common thing in Vulkan that you have not direct but a wrapper, yes, that helps you to ask for some actual things to happen. Yeah. And
so physical device would be the a bunch of parameters you have physically regarding your actual graphics card.
Yes.
And a logical device, it's more of a wrapper/handler for communication between your code and
exactly. And you also described you already ask for the functionality that you want your GPU to be able to provide, if I can say so, and also always you will have to provide this logical device as one of the handlers when you want to call some Vulkan API command, so it can do some not calculations, but like this driver work, for example, like draw something or copy something. You always have to provide this logical device handler because it is your bridge to your actual GPU. Yeah, so it is used all the time during your Vulkan rendering program. Yeah.
Okay.
I really hope that it makes sense. And
Oh yeah. Oh yeah.
yeah,
Yeah.
and
For maybe for the object-oriented people that are used to like have some sort of like an object and like some sort of abstraction over this. Like in the lower level world, it's often the case where you have a bunch of functions, and every time you want to call a function sort of on an object, you kind of provide the object as a parameter. Like this is what really happens if you have an object-oriented programming uh, language. It's let's say it abstracts this detail. Like you have a method on the object, it's actually a function that you call an object with. But in the lower level, like C and C++ API, it's very common to have a function, and you need to pass a handler for a device like this to actually call a function and do something on this device. So this would be probably, as I understand, like a common thing that you have a function and then you need to pass this device to actually do something on the device.
and also here we have the one of, I guess, also important things that we are enabling device extensions there, and it is very important because if we when I talked about instance extensions, they are the extensions, like we are enabling features of driver that is going to be used globally during the whole like this program, because yes, like we want to know that we will render to the window. And when we talk about device extensions, they are only GPU related, if I can say so. And here we are enabling swap chain extension, and we will cover swap chain further in our discussion. And it is very important because swap chain is saying that we are going to render to the window, or to the image, and without that, Vulkan won't know that it has to be rendered to the image. Very, very simple, but like maybe for someone it might seem to be weird that you have to define even these things, but yeah, it is very important in Vulkan.
So I think I didn't get this right. So what is device extension in general? It's like what you want to do with the device, like a
Yes, and for example, the swap chain object about what I'm talking is the image that is stored on GPU, which allows us to draw there and present it. Yes, so it's
okay.
stored in the device memory, and those we have to enable this extension so Vulkan know that it's going to work this way, that is going to store a swap chain image and present it, like render to
Okay.
it and present it.
Okay.
Yeah.
Okay. Okay.
Yes, so after that, I guess maybe, I don't know, do you want to know what QI families are?
Of course.
It is the, like your GPU has QI families, and it is basically the, let's say,
What? How do you type that? I don't think I.
oh, you see it here? Maybe I'm pronouncing it.
Q family.
Q,
Okay.
Q, okay, Q, thank you.
Q family. Yeah.
Q families, and it is basically the dedicated, like let's say dedicated sectors, super high level dedicated sectors that allows us to process API calls according to their type, and when we have this type defined, we are able to efficiently spread the work between these queues.
Oh, that's so cool.
Yes, and in Vulkan, for example, the quiz I know about are graphics one, compute, and transfer. And graphics is obviously related to the graphics rendering commands. So whenever we want to draw something on the screen, let's say, yes, when we will draw, we will put it to the graphics queue that will be processed and managed by Vulkan somehow efficiently, more efficient. Then, for example, and then we will want, for example, to use transfer queue to handle data movement. So when we want to allocate buffer, when we want to copy texture from CPU to GPU, and it will go to the transfer queue. And also for compute, when we want to use, for example, ray tracing cores and want to have a compute shader, it will be all processed on the compute queue. I can't do this.
Let's call it Qui. That's fun.
Queue.
That's
Yeah,
funny.
and
Let's do
and
it
yeah,
Qui.
yeah, yeah,
Qui.
yeah, and like it is helping Vulkan to efficiently manage this work, like
That's so
yeah.
cool.
And the also one thing that I have to add that I totally screw when I was starting this and yet another version of Anthrax-AI, I totally forgot about importance and this like super cool like characteristic of this part, and I just created a graphics queue for everything. And I am probably not a good example of the correct usage of this functionality, but yes, just like as more you know. And I will for sure like improve it in the future when I will make it when I will
Okay.
find the time for that. But I guess it's very cool part of the Vulkan. And
So here on the screen, you're actually doing one Qui,
no,
graphics Qui.
I'm creating graphics and present, but I never use present. I use always graphics.
Where's the present?
Yes, here.
Ah, okay,
Yeah,
okay.
yeah.
I was
I'm like here we are
okay.
calling um, function find queue families, and we are putting
Yeah.
there our physical device that contains the hardware definition, right? And there I can check whether like graphics family is supported, whether transfer family is supported, compute family is supported. Yes,
Okay.
because not
Okay.
all the hardware, for example, can do compute shaders. Yes,
Yeah.
so
Yeah. For everybody who is not familiar, let's do a bit of like w- when the graphics cards were invented, the idea was that it will speed up the rendering. And more and more people were realizing, oh, actually, we can have a separate card for physics. So there was, for example, like physics processing unit, just like there was graphics processing unit. So GPU, there was like PPU, and at some point people realized that like a lot of these functionalities are kind of similar to graphics anyway. So we might just want to have a general thing on graphics cards that we can use for computation. And this is why, like, I'm assuming this is why there are separate families for separate workloads. Because when you want to run a compute shader, so something that will be highly parallelized as a workload, but not necessarily involved in the graphics. It's just that you want to compute something either for your physics simulation or just some sort of mathematical thing. It's not related at all to graphics potentially. So you want to have the ability to influence whether the workload is, let's say, what has the more priority, right? Well, not to have you have just like resources on a graphics card, and you want to have like here are workloads related to graphics, here are to the compute, here's to the transfer, and like let the resources be used efficiently.
amazing explanation. Like really, I think that it makes very much sense.
Nice.
Yeah, and I guess the next step that we should talk about, which is super important, and I will try to make it with the like make sense of it. Okay, so swap chain, as I already mentioned on the stage of the logical device creation, we need to ask like to say to Vulkan that we are going to use this kind of type of object, and it is basically essentially a thing that handles and occur how the images are being swapped and swapped in presentation and rendering. So we have few amount of images which swap chain object handles and gives you when one is available for presentation and one is being meanwhile is being rendered, which might sound like a double or triple buffering for you. Yes? Does?
So the idea is that you can render, so in essence, like compute what are the color values for a given image, but you don't necessarily want to immediately display it.
No,
right?
it is more about when we want to achieve smooth picture on the screen, we want to use like double or triple buffering. Yes, so while one image is being presented, to another is being already rendered in parallel, let's say.
Yeah.
So you can have this smooth interpolation between frames. Yes, and this is what swap chain is handles. It is occurring whether the image is ready for being presented and gives you your application the next image to render in while presenting another.
Okay.
Yes?
Okay.
Yeah.
Okay. Okay.
And for that, we are basically creating objects that are responsible for like our I'm calling these things render targets because it is basically a target where you are rendering to, and it should always have a VK image and VK image views. And basically what is happening here, we are doing such images. It is Vulkan objects that helps us to achieve such render target object. And for that, we need to query whether our graphics card support specific format, usually RGBA. Yes, we want 4-channel texture to make it beautiful and stuff. Yes. Also whether what present mode it supports, and if we will check this helper where I am checking available present modes, it might make more sense if you will see it and like understand what I mean. Preferable mode is mailbox, which is basically our triple buffering. If we don't support it, we use first in, first out mode, which is double buffering or traditional vsync. And it is what you query on this stages. Yes.
Okay. So let me stop you there. So in terms of these three, so triple buffering is the idea that we have a image that is already rendered and we're showing it as frame on the monitor. We are already rendering another one so that we can smoothly show this, change what is being really shown on the screen. And because it's triple, I'm assuming there are three things in place.
Yes.
So like where one is being shown and two other are already being prepared.
Yes, that's how I understand it.
Okay. And FIFO, I'm assuming it's like first in, first out in terms of like
images,
whatever gets there is being shown.
Yes. That's
okay.
That's
And VSync, because it was mentioned, if somebody is not familiar, is this idea that you synchronize with your monitor refresh rate, the rate you actually swap the images. So if you have 60 Hertz monitor, so 60 times each second, you're showing an image. And if you were to, there's some artifacts, especially on the older games, but also the new ones as well. If you have your monitor that is showing, let's say has like 120 hertz refresh rate, and your game is not fast enough to render entire frame in this speed, if you move around the camera, you will see the screen tearing. Like half of the screen will still have the old image, and the lower half will have the actually the opposite. So the the top half will have the new image, and the bottom half will still have the old frame, right? This is called screen tearing. And vsync is was the older idea to sync this like refresh rate of monitor with the how often do you render things on the screen. And the newer solutions are the double or triple buffering, so to render and prepare the frame already so that you're ready to swap it and just show it instead of yeah, like running out of steam when you need to show it. Is
Thanks.
this does
Yeah.
does it
Thanks
work?
for
Okay.
help. Yeah. Really,
I am
really.
actually making sure I get this right. So
I
like
I I I would describe it this way. So yeah, and so just to sum up, before creating an actual image that will be used for rendering on the swap chain object, we need to query like the, for example, the format, whether it is for channel texture or not. For example, if you want to use only red channel, go ahead. Also, we need to query the presentation mode, so Vulkan knows how to swap these images correctly, yes, and change from presenting to rendering. And we need to query the size. And for example, in my case, I'm just doing the screen resolution size of the window. And after that is done, we are creating the images. And after I create an images, I'm creating image views in the next function call. And the difference here is maybe hard to feel, because for me it's hard to feel, but I will try. Images, VK images object in Vulkan is our, let's say, raw image representation. We are defining what, for example, this like format will be, what size of it will be, also the how we will use it in shader, whether we will like use it as a color attachment texture or as a depth, for example, texture, yes, which contains only the depth information, the depth buffer and stuff like that. And also when we created it, we need to create a wrapper around this VK image object, which is basically VK image views, and it is a helper that allows to shaders better understand how to use this specific image. And in Vulkan, it is very important because without image views created from the image, Vulkan doesn't know how to provide this image correctly to the shader. And if we will take a look to this create image views, it is very simple thing. It is just like saying what components of the RGB, for example, will be there. Also aspect mask, which is also definition whether it is a color texture or a depth texture. So a wrapper basically, yes, nothing like nothing big. Yeah. So this is
okay.
for that thing.
Yeah. So again, for all the people who are new to graphics programming and are doing programming in other areas, like if you think about texture, it's actually not that obvious. There are some parameters to the texture that are not obvious. So first of all, channels. So like RGBA, you kind of assume that you have all four channels and you can represent both transparency and like all the other colors that you can imagine. Like JPEG as a format doesn't handle alpha channel. So like you need to specify for a given texture what are the channels. And then you have more advanced parameters like MIP mapping is the technique to make automatically the same texture smaller for various reasons in graphics programming. So you need to say like what is this MIP level? So is this the smaller version of the largest version of the texture and all sorts of other things and parameters. So this is like image spec for what will happen.
Yes, yeah, thank you. I just can't even imagine how you guys can understand what I'm trying to say. Thank you, Łukasz, for support.
Okay.
Yeah.
Okay.
So after that's done, let's briefly check how it's on the side of YouTube. Oh, people, you
Yes.
are still here. Thank you so much for not leaving and staying tuned. I hope that you find it at least a bit helpful and enjoying this.
Okay. Let's see what was happening in the comment section, in the chat. I'm going to Linux soon. It's time. Let's see. Okay, I see a lot of comments. No particular questions, I think. Somebody said Jai, which is quite interesting. Holy C. Maybe this was an admiration of the code.
Yeah, okay, I don't see any questions, I guess. I don't know. Just
Yeah.
yeah. So after that, what's happening next? The device section was done, and I decided to put render targets creation directly after the swap chain because it is like pretty much related topics. And as I already mentioned, that like I call render target the target that we are rendering to, and other words it can be called as a texture. Yes, if you want, if you like to, you can call it like that. And here comes a thing. In more advanced Vulkan handling that probably not happens on during your first triangle. After, when you are going further, you want to handle different additional rendering targets because in the best case scenario, you don't want to render to a swap chain image directly. And you will say why it is like image that should be rendering and presenting. But I will tell you that the main idea of swap chain is that it is responsible to accurate whether image is ready for the presentation and if the next image is ready for rendering. So in order to make it right, you want to have an additional rendering target in between. You begin your frame, you start render to this target, then you copy the result from this render target to your swap chain image, and then you pass this swap chain image for the presentation. And the reason why you need to have this additional render target is because of different rendering techniques that that needs to be rendered to the additional texture first, and then when you have, for example, imagine situation that you have a rendering pass where you render shadows. It is one rendering target. You render shadows there. Then you want to make an SSAO technique. It is like also screen space shadowing. Let's call it like that. You need another render target for that. After that, you have volumetric rendering. You want to render fog, yes, to make your frame scene look dramatic. You need another texture for that. Then you have a final rendering pass when you, let's say, combine it all together to render your objects covered with shadows, with this fog, with this like screen space shadowing, yes. And in your final frame, when you will render this group, you will use these additional render targets that were discussed like earlier, yes, from this rendering passes. And when you have this final frame, you want just to copy it to swap chain, and you are safe, and like you made it very, very beautifully and stuff like that. I'm not sure, do you understand what I mean?
Yeah.
Yes?
Yeah. So
Okay.
like the pipeline is not just let's say, one, in terms of like you don't have just one pass from start to finish. It's just that for lots of techniques like shadows, you need to already have some things on the screen in order to actually compute the shadows, or you want to first want to render something and then you want to render on top of this, let's say fog or something else. So you need more render targets. So that's what I'm understanding from what you said.
Yes, and like it's just a good practice to have some additional textures for that, and just copy the final result to swap chain, because swap chain is very, very specific kind of image that has a specific task. And yeah, it's just good to have something in between where you render and then just copy it. So this is what happens in this function when I'm creating render targets. And main RT is basically the one who handles this like general rendering of objects, and from this texture I'm copying the information to the swap chain image at the end of frame before it's being presented. Then we have dev render target, which obviously is related to our depth buffer, and without that we wouldn't be able to process our objects fragments correctly. And for example, the one which is far away will be, for example, overlapping the object that is on top of the screen, and depth buffer is helping us to prevent this.
Okay.
Yeah.
Okay.
Yeah, and so
Okay.
basically what's happening here is also that I am setting the format, I am specifying the behavior of this texture, so whether it is depth or it isn't the depth, yeah. Also setting the dimensions, and I'm creating render target the same way as we did for swap chain image when I am creating a VK image, and then I'm creating VK image views from that. And these objects will be used during the whole manipulations done with them.
Okay.
Yeah, so I guess that's all for that part. If not any questions are...
Yes. Can you go back for the render targets?
Yes.
And so you had depth render target, a main render target, and mask render target.
Yes, mask is the one which I'm using for outline rendering.
Okay.
Yes, so it is the also like something that wouldn't be possible to do with only one rendering target, and I need an additional one which will be one channel render target, because I don't need to like, for people who doesn't know, each channel, like the more the better texture you have, the more costly it is. Yeah, so for channel texture, RGBA will be more expensive for like the, for example, size of memory size, yes, allocated, than one channel texture. Yeah, I guess it makes sense. And so we need a cheap one channel texture that we will pass into the additional rendering module that will be rendered with the object that I want to then do as an outline thing. Maybe it's also a good part to check the RenderDoc, maybe. I don't know.
Oh yeah.
I
Let's do
guess.
it. Let's do it. So RenderDoc is a super cool utility. I think it's open source, right?
Yeah, I guess so.
So an open source utility that you can use to debug your frames. So one difficult part of graphics programming, apart from all the APIs and arcane stuff and knowledge you need to know before you start doing it, is that you have zero ability to debug this, at least through conventional means. Like you normally, if you have a CPU programming, you can either use a debugger or easily print stuff that's like, oh, what's happening here, what's the value of this variable and stuff like that. And with graphics, it's like you're rendering things and something broke and you have black screen or like a weird artifact. Now what do you do? And RenderDoc is one of these the tools that save you so many hours of pain where you can actually do a screenshot, like a capture of a frame, and see what was happening at the given time.
And I wouldn't be that successful in Anthrax-AI. It's a joke, but of course, but like on my streams, I can spend like a very long time debugging things here. And basically it looks like that. I hope you can see it, yes. And we first need to launch an application and then just capture the frame that we want to analyze. You also are able here to capture several frames. For example, if you are investigating some flickering issue and you have like this flickering things, so you want to be able to capture the one specific frame. So give me a moment, you probably might not see, I don't know. I'll just capture the frame with, for example, this in this status. It was captured because I have not that much of information that being done there, and I'm closing it, and now we have it like this captured frame, and I just will check that you see it, and I will probably move us a bit different way so you can see important things, what will happen here. Yes, I guess like that for now. Okay. So here we basically have the whole information that RenderDoc was able to capture, which happened when we started our rendering and when we ended. We will go to command buffer explanation in a while, but I will just probably show the, oh no, sometimes on Linux it is breaking, but maybe now it will be fine. Let's see. Okay, we will just see what is happening here, what we can see now, different color passes. And just to show and explain the render target behavior, we will check what's happening here. If it's not going to, I will probably need to kill it. I'm sorry, it's freezed. Sometimes happens.
Something happened?
Huh?
Something happened to the frame captured? Or?
Yes, it is sometimes freezed. I don't know. After some update on Linux, it can happen. Give me a moment. I need to kill the guy and rerun it.
On Linux, it can happen, and now all the Windows people are like, "Yeah, let's go."
Oh, I know. It's just not that huge price that you have to pay for an amazing operation system. Sometimes something doesn't work. On Windows, you also have things that sometimes doesn't work.
Also, what is the cool? What's the name?
Huh?
View memory processes and stuff.
Sorry?
What's the name for the utility, the command line utility you see now? The CPU, history, memory, and everything else processes. What's the name?
It is GTOP. GTOP. It's graphics.
Okay.
Yeah, you guys doesn't see it because I am sharing my screen only with Łukasz. So yeah.
Okay.
I'm just.
Yeah, maybe that's much safer. Okay, I'll take a look at the comments in between.
Yeah, okay, but I'm already almost there. Yeah, you can see the back, the RenderDoc. I will just check the other things here. YouTube is not receiving enough media. Okay, I'm not sure what. I hope you still guys can see me, us, and hear us. Okay, I will launch it again and capture the frame. Okay, so RenderDoc. I just, what happened? You don't see it.
I'm checking on the other monitor.
Oh, okay. It's here.
So,
It's back.
okay.
Yeah. So basically, different rendering modules process different rendering operations. First, in first color pass, I want to render my 3D objects only. It's happening like here. We can see how Vulkan is being rendering this 3D objects meshes. And here we
Yeah.
have a frame ready. Yes? Does everyone see? I hope. And important thing is, if we will take a look into this monkey, we can see that on the input side we have a texture, yes, which is
Yeah.
being in the shader sampled and attached to this monkey. And I guess we will go further to look how it is happening, but important thing is that we have here 2D color attachment is my main render target. It is being rendered all this time, every frame, it is being rendered to this main render target. We have also depth render target, and it is all the frame, it is being capturing the depth information. It is, yeah, I hope you can see it. So each frame, it is capturing the depth information, yeah, to the depth buffer.
Okay, can I ask a question?
Yes.
Is it safe to say that what you are calling render targets, the RenderDoc is calling attachments?
Yes, attachment is the basically the definition also of them, and
Okay.
it is just, I guess, yeah, it is the same way, I think. Yeah.
Okay. Okay.
And also then we will have a second color pass, which is probably doing this mask thing. You can see that it is different color attachment, it has different ID. In the best case scenario, I would also like to have some RenderDoc tags for that, so we can better feel it, what's happening, but they are different. Now we are talking about one channel mask render target, which is basically going only through to the object that was selected, yes, because I want to have outline for that object.
Yeah.
So
Yeah.
yeah, and you can also see that in order to make it efficient, I'm also not providing depth buffer here because I don't need it. I'm also able, in my engine, I'm able to handle these things too. So I can have rendering modules according to some rules, and like one will have this kind of attachments, other will have this kind of attachments and stuff like that. And I like, this is one of the things I'm really proud of, that I was able to mix this wrappers and stuff.
Nice.
After
Nice.
is called the outline shader, and it is basically using this original main attachment, and also as a sampler there is being provided this mask render target. So this is what happened here. The outline happens being rendered in the shader with the shader. And the last pass is where the gizmo is being processed. You can see here these 3 draw calls. Yes, we are doing this also to this our main final attachment. And here you can see the final pass is copy, which is also important, the one about I was talking, when we copy to the swap chain image. So yes,
okay.
so you can see the source and we have a destination, and it is like source is our main render target and the destination is swap chain, and then we submit all these commands to Vulkan and process them.
Okay.
Yeah.
Okay. So cool. Nice.
Oh, I'm so
Nice.
glad that I'm so glad that this part of the presentation worked. Okay.
Nice.
Okay.
Okay.
Then let's go check back the command buffers, because it's also important.
Yes. Maybe before we dive into command buffers, maybe it's time for a little bit of break.
Okay, we can do a little break, but I just want to say that we already were talking for an hour and a half, and we are
Yes.
not even in the middle. It's so
Yes.
sad.
Like, it's a lot to cover, and yeah, we'll see how long we'll go. Probably like another 90 minutes is like maximum for me, but we'll see.
Yeah,
So let's
I'm
take
just
a
like
let's take a
before break, I just want you guys to ask how you feel about our stream today. What do you feel before we go to break? Do you like it? Do you hate it? And again, like thank you for being here today and joining us on this.
maybe we can do another poll and see and ask like, oh, how many people are following along, and like whether somebody is capable of following along, or is it like too much? Yeah, I think you can ask some
Yeah. Okay.
generic questions, probably
I
not
need. I guess
generic.
I need to close this end
Yeah,
poll.
yeah.
Okay, I will end it, and then I will start a poll. Do you cover it? Do you handle it, guys? No, how to say it better. What?
How are you handling it?
How are you handling today's stream? And we will have love it, hate it, or no? I don't know. Do we want them to be so straight?
Maybe let's ask like, I'm capable of following along,
Okay.
and the other option would be, it's difficult to follow along. Just as a signal in general.
Yeah.
I don't think we can do much. Like it just like there's some inherent complexity built in. You need a lot of knowledge for graphics programming, and then there's like Vulkan that is not helping with a lot of different names in the API. But yeah, so it's kind of dependent on the experience of any given person anyway. Let's see.
Yeah. Oh. No, it's like since that
I am voting that I am capable of following along, by the way.
tons of info is being covered that we can find in other Vulkan guides. No way, guys. Oh my god, it's so beautiful from you. Because like my like in the initialization code is also like partially taken from the available guides and things. Łukasz, I will just send you the poll results just to not lose it,
But lose
because I
them?
think it's
Okay.
interesting. Yeah. So
Okay.
okay, then you want to have a break and like 5 or 10 minutes or more?
Let's take 10.
Okay.
Let's take 10 minutes.
Okay, then in 10 minutes we will be back. Thank you guys for being here.
Okay.
Okay.
See you.
Hi guys, can you hear us and see us? We are back.
1, 2, 3, 1, 2, 3.
Yeah, I will put microphone closer. Yeah, so we are back. And again, thank you for your response. It is so nice to know that you find this content fun and important. Yeah, so thank you for being here today.
For the person asking about switching to Vulkan for game engine stuff after being an application developer with years of experience, I would suggest focusing first on like defining whether you want to do really whether you want to do game engines and rendering part, or whether you want to do like games, and then see where you land with this. And for the game engines, probably start from some sort of tutorial. There is an excellent tutorial, learnopengl.com, freely available. And like, I know that you started, Maria, directly with Vulkan.
Yeah.
A lot of people are starting with OpenGL and then have a bit easier time to go into Vulkan. So yeah, starting everything, like if you don't know C++, graphics, programming in general, and Vulkan, and trying to do this all at once, it's very difficult.
Yeah.
How have you started? How come have you started directly from Vulkan?
Well, you want to know my experience, yes,
Yeah.
my opinion.
Yeah, yeah.
I don't know. It was hard, and from like I guess people who follow my channel, they might know that I have no technical background, and I was studying architecture-like thing at university, and I found myself into programming after few attempts to make games on Unity and Unreal, and I didn't like after some of attempts I understood that I'm actually not interested in game development itself, and I want to know more about how things work under the hood. And I had a very big obsession when I was 20. It was like 4 years ago. Five. I had a very big obsession to understand how pixels are being able to be presented on the screen. I just wanted to understand it so much that I guess one of the my big dives into programming was with a low-level assembly, like with the assembly language, and I was writing 16-bit applications for MC-DOS because it allows us to use registers and CPU directly, and that's how I started my path. I was able to understand how we can access video memory for such retro systems. And after that, it took me some time to know about Vulkan, and it happened on one hackathon when I was in this my maniac stage of discussing of how I will write my graphics driver to understand how pixels work. And one guy said that I need to write my Vulkan then. And when I heard it, I decided, wow, it sounds complicated enough. And I've decided that maybe a good step before writing actual graphics driver will be to get familiar with Vulkan. And it was almost 3 years ago, maybe 2, and since then I'm just learning it and trying to understand, because from my perspective, I would not recommend to start with OpenGL, because it will help you to understand, I guess, essentials of the graphics programming, but it has nothing common with the Vulkan API. I guess it is just a different API. And it is a different abstraction and a different way of thinking about how to communicate with the hardware. And yes, but like I guess it's just all individual. And yeah, I just started to go through tutorials. We have like good Vulkan tutorial series on. Yeah, I have links also available with a chat comment, bot comments. Yeah, it's just vulkantutorial.com and vkguide.dev. And I was writing several of applications using that tutorial series. And only, I guess, when I started to do this YouTube channel and I've started to work with the 3D graphics, I actually started to understand how things work. So like for me, it was a very long path, like maybe 2 years before I started to really understand what's happening in Vulkan. Yeah. And I assume that people who have a technical background, they can understand it more fast because of some, I don't know, required thinking of things, understanding the hardware and software things. I don't know. I just had to do a long time to get there. Yeah.
No, I think it usually will take a lot of time to actually get there. And you also had some low-level programming experience, so you kind of knew what to expect from an API.
I wouldn't say so, because direct access on which gives you MC-DOS and assembly on this like way is very, very different of this abstraction model that you have with the APIs. I don't know, like, yeah, but still after lots of attempts and frustration, you got there. It is just, I guess, you have to have a very big, I guess, motivation for this topic. And you have to be very, very curious about that, because it takes time, yeah, to get it. I will just open the door for my cat because she is awake.
Okay.
Yeah.
Okay. Then I think we can continue.
Yeah. Command buffers is a very, very interesting part of Vulkan, and I think that we can also get to the RenderDoc pack to see it with our eyes, I guess, what everything it means. And it is important to know that in order to ask something from your GPU, you need to store it somewhere, and Vulkan provide us such option. And the command buffer is basically a container that is storing all API calls that we are doing to Vulkan during our rendering. And it is pretty simple concept, I guess. It's just a buffer which can either record the commands that you want to use or and execute them. So it basically has a life cycle that your commands are being first like reset, that then they are in recording stage, and you are doing all this, like, I don't know, memory transferring, drawing calls and all this stuff. You are recording them, and then you are submitting them, and then they are being executed. And the difference, as far as I know, it is a difference, maybe I'm mistaken, but in OpenGL you have like commands that you want to ask from the API to be executed. They are being executed one by one. Vulkan is recording the whole set of it. It's like a to-do list, yes? To-do list for the GPU. It is being recorded, and then he push it to the execution and can efficiently somehow process these commands internally. So does it make sense?
Yeah. So from the API point of view, you create a command buffer, you add commands, like things for GPU to do there, and then at some point you will submit them, and then they are submitted in batch. So
Yes.
it's probably more efficient than OpenGL, where, for example, you just issue a draw call, and in the moment you're issuing a draw call should happen.
Yeah. It is also, I guess, the reason why Vulkan allows us to use multi-threadings on such stage. We can use multi-thread to record comments from different threads, and it is like very, very cool feature of Vulkan, I guess, which is not
Oh,
possible in OpenGL.
so it's like synchronized
Yeah.
in terms of access, right? Like you can just add from various threads. Oh, that's cool. That's cool.
Yeah, I never implemented it myself, but I have it in mind, and whenever I will have a time for that and knowledge, I will definitely do this because it sounds so exciting. And yeah, so basically this is for the like high level overview. They are also QUI specific. So if we have different QUI, as I mentioned earlier, like compute QUI or graphics QUI, it will be a different command buffers for them. Because I guess it's also somehow that somehow helps Vulkan to identify how to process that batch of commands. And also, I guess to mention is the one interesting also thing that we, like you can see here, happens the main command buffer creation and allocation, and and this is let's actually go to the RenderDoc so I can show you the idea of it. It is very, very simple. We have here, before we start our actual rendering, we have a function called begin command buffer. So at the end, at the beginning of the frame, we start the, let's say, recording stage of this command buffer, and all these commands, wiki-cmd begin rendering, draw indexed, wiki-cmd draw, wiki-cmd end rendering, then again begin rendering, blah blah blah, all these things go to this main command buffer for our main frame. And also, for example, this copy of the image from main render target to the swap chain image, it all goes there. And at the end, we are ending our command buffer. We are submitting this command buffer to execution, yes, to driver. And after that is being called this QUI present KHR function that is actually presenting to our screen. So this is the life cycle of command buffers.
Okay, so you, during like initialization, you create a command buffer and allocate memory, do all sorts of stuff that is needed. And then during the frame, you will render the command and submit them. Does it make sense at any point in time in the future to have like more than one command buffer? Like
only for different queues, I guess.
Okay, so the command buffer is per queue. Okay.
I guess, yeah, and I wouldn't think, at least I don't know about the practical usage of more than like one main command buffer during the frame rendering. I'm not sure if it can affect performance or no, so I wouldn't comment that. I only know about one main command buffer being in use. And I guess it is also important because like probably they are the commands being processed one by one, like when they are being pushed to the GPU. So it would make sense to somehow ensure proper communication between your API calls. So for example, your first command buffer won't be executed before the next one and stuff like that, you know?
Yeah.
So yeah, this is about that. And also here's an interesting thing, because I'm creating another command buffer after the main one, and it is like how we call immediate one-time command buffer, which is basically used only during one-time operation that happens before the main frame loop. And these operations can be applied to, for example, when I am allocating and creating textures from CPU to GPU. Yes, so my GPU can use it in shaders, for example, some textures that we are covering our 3D models, yes. And I want to store these textures in GPU memory. And for that, I need to use Vulkan API calls. And for that, I'm using this one-time command buffer that will never be executed during the main frame loop rendering. Because it's just like how I read it on the tutorial, and it made sense to make it this way.
Okay. Command pool is like a sub resource.
No,
here?
it is how from what we are allocating the buffer itself. So pool is just like the let's say place in memory. I would understand it this way. Yeah.
Okay.
So okay. Then other very important topic, the synchronization mechanism. And Vulkan allows us to use different synchronization types, and they are all important. We need to handle them because otherwise we would experience very dramatic situations during rendering. And I know that the synchronization in Vulkan is very powerful, and the way I am using it is very beginner way. I am not doing anything like interesting, like my knowledge there are also very small, so I will just try to cover the basics, but unfortunately I don't feel capable to talk more in detail about that. But in Vulkan, the main synchronization types are semaphores. They allows us to synchronize work GPU to GPU. So, for example, it might be this synchronization of semaphores is invoked when we are trying to synchronize frame between rendering and presentation. So we won't have any like bad situation when we are trying to present something that wasn't finished in render. Yes, so so GPU doesn't read the information before it was actually written. Yes.
Okay.
Yeah. Then we have fences. They allows us to sync between CPU and GPU. So, for example, the situation when we are trying to copy the image from the CPU, that is the textures again, to the GPU. Yes, so we are also not trying to access some slot that wasn't transferred from the CPU correctly. Yeah, and like stuff like that. And also we have pipeline barriers that aren't being like created on the initialization stage. It is just an API call which allows us to be sure that when we do our like pipeline processing, for example, when we are processing our material, yeah, so the blocks of memory that, for example, the attachment that it's using, like the textures and stuff, they are safe, and for example they are not overlapping in between, so we are doing this pipeline barrier, so we are sure that the memory will be safe when we are trying to read from the texture or write to the texture using shaders. Yeah, so
okay. So there are three things here: semaphores, fences, and barriers.
yes.
And semaphores are at least used here to make sure that we don't render something that is not presented yet, so it's not done yet.
Yeah, it is internal like synchronization in GPU, I would say. It is like when we are providing them, we are waiting when the one semaphore will signal that, for example, it is ready, like for rendering, yes, and we can like continue our like rendering.
Okay. Fences are for the CPU and GPU communication, And there are also barriers for.
When we try to process our graphics pipeline, it for example awaits that it will receive some textures, and we want to make sure that this block of memory where the texture is lying is safe, secured for this pipeline process. So
Okay.
that the other, for example, pipeline is not at this moment writing to this texture. If I can say it
Okay.
very, very
Okay.
like, high.
Okay.
Mm-hmm.
Okay. I see how this can be complex
Yeah.
to set up and then debug.
Yes, and from my perspective, I am only using it, let's say, without pipeline barriers. But if we will talk about semaphores and fences, I'm invoking them only twice, when I start the frame and when I'm finishing the frame. So in my setup, it is very simple and pretty much safe. So it's not like crashing or whatever. But I guess if I will one day go deeper, and especially if I will do multi-threading, it might
It's gonna be fun.
yeah, probably.
It's gonna be fun.
Probably.
If you were to comment out this function now, and you wouldn't have any fences semaphores now, would you have any problems?
I would expect some corrupted rendering, because when we are not sure whether GPU finished to receiving some information from CPU, for example, when I'm trying to copy from I don't know, from the texture to the render target or something like that, I think it might be very dangerous. I don't know.
Okay.
I don't know. You want me to try? I can try.
No. We don't need to. I mean, if you want to, actually, because your loop is quite fast. So
Let's try.
if you want to
I'm
try,
not sure.
because I wonder, because definitely the more semaphores and fences you put in, I'm assuming you have less. It will limit the performance somehow, right? You cannot do something. And I was wondering whether it's possible to have the code execution logic, instructions put in the proper way, so that you don't need them, because you're only doing this. But on the other hand, it's not like you're doing the sequential processing in a CPU program. It's more like you're talking to a living thing that is doing separate stuff, like GPU. So you kind of don't know and don't have any guarantees on when it's done processing. So yeah, maybe that's the case.
Okay, so for example, on the when I'm starting my frame rendering on the in my rendering loop, when I'm beginning the frame, I'm also resetting the fences, and basically what is doing sync frame is actually returning you an index of the new swap chain image from this image pool that I have. Let's say it's 3 images of swap chain, yes? And each frame I'm acquiring the next image, because as I mentioned earlier, one is, for example, presented, and the next one is ready to be rendered, yes? And the third one is already with some information, and it is awaiting to be presented, let's say like this, yes? So here I am also waiting for all the CPU tasks to GPU being done, and I'm acquiring the next image. So if I'm commenting the wait for fences and reset of fences, I don't even know what to expect would happen. Maybe nothing, but we'll see.
So yeah, no, but even if it still works, it's now you have no longer a guarantee.
I have lots of Vulkan validation errors. That's first thing.
Okay.
And yeah. And it is actually being updated, but lots of.
Okay.
You see that command buffer isn't being properly synced, and I have also some wow,
Yeah.
future error. I don't know
Promise
even.
already satisfied.
So,
And then there's like, it's already in use and it's not marked for simultaneous use.
yeah.
Vulkan spec states. Okay. Okay.
So
Okay.
something is being bad when I am submitting or resetting the common buffers, because probably, yeah, and like I guess in my like in this like simple situation we won't see any like issues, but like imagine a huge scene with, I don't know, like lots of rendering modules being processed, and I guess it can, and like with the multi-threading it can
Oh, yeah.
result in things more crucial than just Vulkan validation errors. Yeah.
Okay.
So after that, you can probably go to the texture creation, because like I'm not sure, like, yeah, I guess we can check it. And
Yeah.
it is very like now simple, since I'm trying to have this opportunity to select in the editor which texture you want to apply to the model. I'm also trying to upload all the textures from the asset texture folder, yes, which I have there. So I'm just basically gathering the names of them. You can see it. Oh, let me. Oh, wait. Yes. So I have this my like project structure, yeah, and you have asset folder, and you have textures here, and here are the textures that are available then in the editor. Yes.
Yeah.
And I'm gathering the names, and then I'm going to create them. And this is very, very simple. I am using STB texture loading library. Yeah, it's very small library to uploading the images, and basically when I'm calling the upload, I am retrieving the pointer of the data for our like texture, which then will be passed into the GPU. And in order
And
to
by the way, sorry to interrupt. STP, made by Sean Barrett, extremely popular, great library, one file library, pretty much, just a header file. Incredible stuff, great programmer, Sean Barrett. Look him up. He worked on rendering on Thief, the original game Thief.
wow,
Incredible guy.
have you take an interview with him?
I reached out to him, but so far no response. But let's see.
Okay. I finger crossed. It will be very interesting for sure. It's okay. So yeah, it's nice that you know it and that you love it. So um, anyway, when we receive this pointer of the data that is stored in our texture, we want to somehow transfer it to the GPU, and it is very important moment here, because as you probably know, we don't have an access, a direct access from CPU to GPU. So for that, we need to use staging, this is the name of the buffer, it's staging buffer, the buffer that is temporarily created and then free after it is being used. Yes, makes sense. Yes.
Yeah.
And for that, I am also allocating this buffer with the size of the image, which is basically width per height per channel amount, yes, of the texture. So I am allocating this buffer, and I'm also setting the corresponding Vulkan flags, so he knows how to use this buffer efficiently. And for example, here we have memory properties flags that tells Vulkan that this will be optimized buffer for transferring from host to device. So from the CPU to GPU. So this is like this bit flags we are using when we want to achieve this buffer result. Yeah. Then we are mapping this memory. So but like basically the buffer object that I have here is containing three things, like, and important are the first two. It is Vulkan buffer handler and Vulkan device memory handler. So when we are creating this buffer, we also allocate ask to allocate the device memory in our GPU for this buffer, and then we can use it. And we can map this memory, and so it knows how to, like, so we can put our texture data into this buffer, into this special memory block. Make sense?
Yes.
Okay, great. This is done. Then we can free our pixel, retrieved pixel information, because, not pixel texture information, because it's not needed anymore. We have staging buffer with that. And now, after at least like creation of render targets, the same way as we did for the attachments we talked previously, it now has VK image and VK image views object. And now we are ready to make some memory barriers, so we can have a proper Vulkan CPU to GPU transferring of data. And here comes also in the game our one-time submit buffers, because we basically tell that now we will have this function call, which is doing image memory barrier. And here we have the pipeline barrier that I talked earlier. And this call will be submitted during, like in runtime, if I can say so. Yeah. And why we need the memory barrier? Because when we want to properly set up a resource in the GPU, we need to also define a proper layout for it, so the GPU knows how to work with that. Yeah, let's say first our texture is in an undefined stage. GPU doesn't know how to work with that. Then, before we want to copy this resource from CPU to GPU, we need to put it into transfer layout mode. So GPU knows that it is going to copy this data to receive it. Yeah. Then when we made this barrier, we are calling wiki-cmd copy something, probably another command, but anyway, now we tell that we want to copy from this buffer, yes, to the GPU. We are wiki-cmd copy buffer to image. Yes, so it will copy from this buffer to our VK image thing.
Okay.
Yeah, so it will have this thing there. And after, we need to again make a memory barrier. So in our future usage of this object, because we want to use it as a sampler in shader, we also need to define this for to GPU. So we are again doing this barrier to change the layout from transferring the data to shader read only optimal layout. It is basically telling shader that it is GPU that it is going to be used as a sampler.
Okay.
Maybe it is a bit I don't know if it's difficult or if it is like, if it doesn't make sense for the listener, but I tried.
No, for me it's on one hand fascinating, because like you can like conceptually make sense of, okay, I'm reading the texture on a CPU and I want to put it somewhere on GPU
Yeah.
for it to be used, right?
Yeah.
But the number of steps you actually need to do
It's
to make sure
fascinating.
it's there on the right place, and it's like you have memory allocated, and then you like first you switch the mode, then you upload it, then you like copy it, and then you like switch the mode again, and now it's gonna
Yeah.
it's gonna be read only, it's gonna be right. It's like, Jesus, it's so much stuff.
Yeah. Like, it's just like this part with the layouts was also one of the, like, it wasn't super difficult, because when you just open the specification of Vulkan, you just wait, specification? Yes, it's correct. Yeah, you just like this like things make sense, but it is still like kind of takes time to start to think that about these things too, you know, like just to keep it in mind that you, for example, have to put something to the proper layout so you don't have an annoying warning from validation layers and like stuff like that. And yeah, it is very
Yeah.
yeah. So
Okay.
this is how textures are being created and accessible. Yeah. So after that, also one of my favorite parts, the descriptor sets, and it I guess like this for sure was the one of the most difficult uh, parts from Vulkan that like took me years to understand, like really years. I was like also lost with that, what it is. And like before the stream when I was preparing, I think I really hope that I found proper way to describe it. And
Okay.
yeah, and like essentially descriptor set is the mechanism that helps our GPU to access external resources, like not even GPU, like shaders to access in external resources. And you can think about descriptors as about pointers to these resources. It can be like texture or buffer, yes, like things like that, that is use in shader. And descriptor set is simply a table of such pointers. And I find this like explanation very covering this thing.
Yeah.
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 So.
So from shader, if you want to access some sort of GPU resources
Mhm.
like buffers, textures, you can wrap this in a descriptor set.
You not can, you must.
Okay, you have to.
You
Okay.
have to. You can't
Okay.
either way provide your shaders the resources. It is
Okay.
only done
Okay.
through the descriptor sets. And like in traditional way of the descriptor set setup, you will have to create a descriptor set layout, which will define what kind of resource you will have, for example, buffer or sampler. Then you will have to allocate and create a descriptor set with that. And then when you will provide this resource, you will have to update the descriptor set so it will store this like pointer to this resource, if I can say so. And after,
Okay.
before doing the draw call, you will want to bind this descriptor set with your like pipeline and stuff. So during the graphics pipeline, this resource is accessible. Yes.
Okay. Yeah. So maybe I can chime in. I'm not sure whether this is the case for Vulkan. It might be, but in terms of OpenGL, a lot of the times what you do is like you create a resource like a buffer. You have a handler for it, like a name, like the identifier, and you kind of forget about it. And then when you want to use it, you actually bind it. So it's like, oh, enabled, let's use this. Okay, unbind it. So like disable. And so this is the same pattern
Yeah.
as far as I
Yeah.
understand. Like you prepare this, and when you want to access, like bind, now it's active, we're doing something, not bind, unbind.
Oh, so you don't have like, I thought that in OpenGL you have implicit way of using this resource bindings, or you have also to bound it explicitly.
So as far as I understand, there's no resource bindings. Like there are no the descriptor sets like this in this case. Like there are none. But if you want to have, let's say, if you want to use a texture, right? You need to bind it, use it, and then unbind it.
Okay. Okay.
So like this binding, unbinding thing. So like you initialize it, like prepare it, and then before use you bind, use, and then unbind. Like this kind of pattern exists, but not for the descriptor sets, as far as I understand. But I'm not an OpenGL expert
I see.
at
I
all.
see. Yeah. Well, then if to go uh, back to the Vulkan traditional descriptor set
Yeah,
handling, because I use a bindless descriptor set design for
yeah,
handling this setup. And just to cover probably before how it could be done in the more traditional way, I guess, then usually when you want to provide your shader some like source of the resources, you will have descriptor set per resource. So let's say you have a situation when you render a cube and it will have a sampler provided, uniform buffer for storing the camera transformation and stuff like that, and instance storage buffer, which will store object rendering transformation. Yes, it's like a model matrix. Yeah. So you will have 3 resources. You will need to create 3 different descriptor sets, and each rendering, each time you render a frame, you will need to bind 3 descriptor sets and provide the corresponding layout setup in your shader. So you will know that, for example, on the bind 0 you have sampler, on the bind 1 you have uniform buffer, on the bind 3 you have storage buffer. Yes, and this is how it is done traditionally. And from what I understand, it is getting very overwhelming and frustrating when you have more complex situation. Yes, when you have lots of objects, lots of materials, and just imagine handling and storing all these descriptor sets. It is just like very, it's starting to be ugly and very complex. And also each VK CMD bind descriptor set call is a costly API operation, because it is very costly all the time when you want to communicate from CPU to GPU. Yes, things. And Bindless descriptor setup allows us to reduce this amount of API's calls to just 1, because we store all our resources in a huge descriptor set array.
Okay.
Good explanation.
Yes.
Yes.
Good explanation.
Amazing. So in my case, I'm not sure whether it is possible to make it dynamic, the size of your bindless descriptor set. But I have it static because it is easier and like just I am learning things. So I have a static size of this descriptor set, bindings points, 1000, let's say. And each time when I am processing my object that will be rendered on the screen, it happens before I start the rendering. Yes, it happens when I am reloading resources, when I'm uploading a scene. I am understanding how many of objects I will have, what type of material they have, and according to that, I also understand what resources they will have. For example, 2 buffers and 1 sampler, or 3 buffers and 0 samplers and stuff like that. And each time when I'm processing it, I am calling the update descriptor set command, and I am binding the corresponding resource to the unique index, because it's an array. Yes, so I am just pushing the corresponding resource to the corresponding index, and this index is being kept inside of the object. And when I am rendering to the shader, I am providing this unique index, and with this index I am grabbing the desired resource. Let me show you better it in some shader, because it might be easier. Let's check the sprite fragment shader. It's very simple. It is just taking the texture from the texture array and according to the provided coordinates to basically do super easy UV mapping, yes, of the texture to the 3D to the sprite object. And you can see here that I am taking the name of the sampler using my texture array of descriptor set with the texture index that I am providing. I think that I went too complex.
So sure. I think I got it, apart from one thing that is crucial. How the get texture index knows what to return?
It is being pushed on the every frame index frame rendering loop, it is being pushed to the such let's say resource type of Vulkan. It is push constants. It's very simple, small amount of data that can be very easily pushed during your rendering, but it's not important, I guess, because this index is being applied on the CPP part when I am initializing all the objects, and when I want to put the corresponding texture to my descriptor set array, I am calling the update function, and it is returning the index which I am incrementing each time when I'm calling this update sampler function. So for object 1, the index will be 0. Yes, I called update, index was 0, I stored it and I pushed it to the shader. And now I know that for this object 0, the index is 0. For object 5, when the update sampler function was called, index was incremented, that it will be 1. Yes, and I will store it for the object 5 and so on.
Nice.
Yeah.
Nice, nice,
It,
nice.
now it makes sense?
Yes.
Oh,
yes.
okay,
And it's
okay.
also cool.
Okay. And I guess also a very important thing is that RenderDoc is also a big helper here, I guess. Let me just open it. And if we will check my monkey, we can see that it has a sampler provided. And also it has 2 buffers also provided, and we can see everything here. When we will go to check the pipeline things, we will talk about pipeline stages later, but just now to cover this descriptor set thing. Here we can see the descriptor sets that were bind. I have only one, yes, you can see it here. And also we can see now resources that were bound, and it is just amazing because we can see this which set it was, and I have like 3 bindings for sampler, for uniform buffers, and for storage buffers. And we can check it here, for example, that we have a set descriptor set 0, and the binding for corresponding resources. And here you can see which index it was. It had, for example, 24, and it will be using the instance resources that were stored in the descriptor set array in the position 24. Okay?
Okay.
Yeah. And we can also click on it and check that what I have here, I have bone matrices, and like it will be lots of bone matrices. And I have render matrix, which is basically the modal matrix. And I also has some like things here for different types. It doesn't matter. Oh, you can see it actually here, what it is. The struct of instance data that I'm passing. And also same here for camera buffer, which has like mouse position, view matrix, projection matrix, and it is also, you can see it is also being accessible by index 22, for example, here. So this is how descriptors are being managed. And for fragment shader, you can see I have an array for textures, and by index 7 it got this texture. Yeah.
Okay.
Okay.
Nice.
I'm not sure, but like I really hope that this part was fine.
Well, it's a lot to take in, so like
Of course.
you all like I'm hoping to get at least 80% of it.
Yeah, but like I guess that
Alright.
the basic understanding that it is just pointers
The
to
idea, yeah.
resources, it is very
Yeah.
very like covering enough to get the
Oh yeah.
yeah.
Oh yeah.
Whew.
Yeah. And by the way,
Yeah.
I just realized like big shout out to RenderDoc creator who also has awesome name Baldur. Like Baldur's Gate, he has a
Wow.
name Baldur. Like
Okay.
for real. So like big shout out to the guy who made this open source project and is like capable of doing all sorts of debugging for graphics. and he's still doing it, still maintaining it, developing, adding new features. So like great guy, and cool name.
This
Okay,
like I'm
sorry
just
for
wondering
another.
if you will be able to get interview with him too. I'm sure that it might be very interesting. Oh my god.
All right.
Okay.
Okay, let's be mindful of time. It's 6:30,
Yeah.
so we probably can do like allocate buffers, and then
I would no, like if we have, how many time we have, because I would skip allocate buffer and do pipeline check out.
so we'll probably like 30 minutes, and then we're gonna be closing out soon. That's on my end.
Okay.
How's that? So we can skip the allocating part and go to the pipeline.
Yeah, because I think it might be very beautiful part and interesting too. First of all,
Nice.
I should mention that pipeline code is one of the most chaotic one, but I tried to generalize it as much as I could, but also to not. Yeah, I will just start with the part to bind it with the descriptor sets. For pipeline, we need to create a pipeline layout which will know how to work with our shaders, with our materials. And also, as Łukasz mentioned on the beginning, graphics pipeline has several stages that are, some of them programmable, some of them not programmable. I guess we will not go deeper through all of them because we don't have time, but stages are that first one is input assembly. You receive raw vertex data, then you provide them to vertex shader where you apply transformation matrix to understand how your vertex is working within the world. Yes, with your camera applied and like all this like projection matrices, so you can see it very beautifully realistic how you want to see it with your own eyes. Then comes rasterization part, which Łukasz covered very good at the beginning, and I will not copy his words. And fragment shader, when we are coloring our fragments and the final picture is on our screen. And pipeline layout creation covers all these steps. In Vulkan, it is very beautiful and interesting that you can actually at least touch a bit all of these steps. You can't, for example, do a lot with it, but for example, even input assembly, when you are defining this stage which is not programmable, you can still say what primitives are going to be there. Yes, and here we are defining the triangle primitive. And you can, for example, see what you have here, like as primitive topology. Yes, it's like can be point, line, whatever. Wow, I didn't even know that so many of them exist. And yeah, I'm not sure if I'm maybe too fast. I'm trying to.
No.
No, fine.
No,
Yeah.
it's okay.
Okay. So
okay,
also
yeah.
important part is that you define the viewport size and scissor. And viewport is basically the size of your screen if you want to render it from 0 to the width and height. And scissor is how you're going to process this final picture. For example, you can make an offset so it will be rendered only from like starting from the pixel 100, and I can show it in the real time. So if we will modify this value, we will then after compilation see how it looks, but I will also make some other modifications and we will compile it in once so we can see. So rasterization create info is also very interesting because except of the like general information that you have here, you can also enable or disable rasterizer discard parameter, which is basically telling you whether you want to pass your pipeline through the rasterization stage. It might be very useful when you want to use Vulkan for computation only and not for rendering. So for example, if you will make it true, this parameter, your pipeline will never go through rasterization and fragment shader stage. And it is really cool. Like it just will go, for example, for computation. Yeah.
That's interesting. I
Yeah.
didn't know.
Yeah.
I didn't realize that you
Yeah.
can do that.
Yeah. It is very cool. And also then you can define the cool mode. So how your fragment's going to be discarded, yes, according to what rules. And also the other interesting thing is that we are providing the filling mode, and here is a polygon mode. So we are rendering, like rasterizing all elements inside of the triangle, yeah. And if we will see what other modes here are, we can select, for example, line, and it will be rasterized as we know wireframe, or how it's called.
Wireframe.
Yes, yes, and it is also really, really sick and cool. And for example, now I guess if I will compile, it might be very interesting moment. I don't know. It's just like when I was playing with that, it was very, very funny. Yeah, and while it's compiling, just tell about some other things that here happens. I'm also
So well,
yeah.
just let's make note of the two changes you
Mhm.
you added, right? So you made the scissor offset on the x-axis from 0 to 100, and you switched the rasterization from polygon mode fill, so for each triangle to fill in, let's say, all the pixels within, to line. So now let's say the fragment shader will be run only on the edge, like
Yes.
on the line between the points, not within.
Yes.
Okay.
Okay, then
Okay.
let's run it just to see. Oh, okay. For example, now you already see
Yeah.
that it is very, very funny here.
Yeah.
But
Yeah.
it will be better when we will launch the scene. Just I will check that everyone can see. Yeah, scene with the objects, and it is
Oh, yeah,
very
yeah.
cool. It is so cool.
Yeah.
And of course, you can see that the edge here is not drawing because we have a scissor offset of 100. You see it?
You mean the left? Yeah. Left
Yes, it
edge
is.
yeah.
Yes.
Okay.
So yeah,
Okay.
you can see it better on monkey here.
Yeah.
In other
Nice.
scenario, we would render from the zero. Yes, and
Yeah.
now we are just discarding this part. And let's just check. For example, we can change the monkey texture to make it more visible.
Yeah, because you're still running fragment shaders, so you can still color the lines,
because
right?
you can see here it is also the sampler, the texture is being applied to these lines, and it is so funny. And you can see somewhere that it might be written powered by Anthrax-AI, somewhere this like yellow dots. So it's super cool. I think I was really having a lot of fun time with that.
Nice.
Okay, that's all for this funny presentation. And let's return to serious business. Shader compilation happens here in real time. When I
Okay, so let's recap. We're starting building the pipeline, right? So all the stages of the pipeline need to be created, and in here, and there are a couple of things like, let's say this is, I would say, sort of like a central thing to the Vulkan stuff, right? Like we were preparing a lot of resources kind of for this stage to happen, and now they will all be used now. So, and we're gonna have a vertex shader stage, rasterization, and then the fragment shader stage. And nothing in Vulkan happens on its own. Everything needs to be done from scratch. So even the thing like reading the shader code and uploading and compiling needs to be done. And now we're gonna move towards this section where we actually handle the shaders and make GPU aware of them, right?
Yeah, yes. And for that, like, let's just ignore the part where I am updating them according to the scene file provided, where I define what shaders will be applied to each what object. And let's look, for example, to this very simple intro intro material that I'm using for this intro part when I'm starting the engine. Yes, I'm just here like hard coding the names, where to find this shader, vertex and fragment, and I am using shader loader, and Vulkan SDK provide oh no, not this part. This is just creating a shader module for with already compiled shader. Sorry, I am compiling a shader with the provided Vulkan SDK library shader C, and it helps us to compile from GLSL code to SPV module. It is binary representation for Vulkan to know how to communicate with shader. They have like SPRI.
PRV.
Yeah, I don't know
PRV.
how to pronounce
Yeah.
it.
SPIR-V.
V
Yeah.
or 5? I was always saying 5. Anyway, but
I think it's PRV.
oh,
So
okay, it's
maybe
PRV.
again, maybe again I'll interrupt you,
Okay.
but to make this a bit more clear, like just like you have a lot of programming languages for CPU, you have a lot of programming languages for GPU, and since GPUs are, I mean, maybe not like more close than CPU, but like the spec is more close usually. The languages are sort of almost similar, but not quite. And uh, Vulkan is being made by the Kronos group, and the mission there is to make one uniting API for everybody. And this is also uh, relates to the programming language. So for shaders, so there is a programming language called GLSL, stands for Graphics Library Shader Language from OpenGL GLSL. And for example, Microsoft has its own for DirectX. It's called HLSL, super closely, like just one character of difference, actually entirely different language. The idea with Vulkan is that you can compile a shader from GLSL to SPIR-V, which is this binary representation. But the Vulkan people, Kronos group, and other people can provide a tool to compile other programming languages like HLSL from Microsoft, other shaders to this SPIR-V immediate representation. And this way, each shader that is written in a different language can be compiled to the same intermediary representation, just like other languages to LLVM immediate representation. And there you have like, okay, now we can only care about SPIR-V thing. So this is like a mission for Kronos group to make this kind of unified across all the other like platforms and providers. This is why it's like there's this weird step of in between
Yes.
language SPIR-V.
Yeah,
Okay.
exactly. And thanks for adding this thing. Yeah, and basically when this happens and you have this final module, you will pass this buffer with the compiled binary representation to create an actual Vulkan shader module that it can use. And of course, it has to be already in this SPV representation. And it basically takes this buffer and tells that it is shader module and creates that. And yeah, so, and if you had any like issues with your shader, you on this stage will know about that. And yeah, so that's how it happens. You just have these shaders, and then you just set up a pipeline for that, and it is very big things that you provide there. Mostly here, for example, we are just using the information of the input states that we already defined on the top of it. So for this like input assembly stage, viewport size, and how we will process the depth information and stuff like that. Yeah, and also here you define what amount of color attachment you will have, how what depth buffer you will have, what format it's going to have. It is all very important to Vulkan to know how to build this pipeline correctly. And then you just create it. And then I will have the final step of the material creation, which is basically a map that stores the name of the material as a key and pipeline and pipeline layout in it. So when I am rendering some object with the corresponding material provided, I can grab the corresponding pipeline and pipeline layout while rendering. So this is what essentially material is in Vulkan.
Okay, yeah. Because in like normally you wouldn't have this like pipeline layout part. You would have like in the OpenGL world, you have this like pipeline kind of established, and you have a material, and material is really like a shader plus parameters. So for example, if you have a shader, and let's say you pass like a color to it, right? So we have like, okay, this instance, let's say we have a shader and like color red, and also we can have a shader and the color yellow, and you have like two different materials. But here you need to bind this to a pipeline layout, because in theory you can have like two entirely different pipelines. And so you need to map them, like more things can be changed. So material is a bit like bigger in terms of what it contains. Okay.
Yeah, then I'm not sure like if you want to continue with other things, or already will somehow like finalize today's session, because lots of things can be said.
So this is just initialization, right?
Yeah.
We didn't even get to the like render a frame.
And like I'm
blah,
really
blah.
like I'm really proud of how I'm doing this. I know that it is still super stupid and super, I don't know, not
No, I think-
professional way, but like the part how I'm handling frame rendering, I'm super proud of it. I just really love to play with it, and it would be nice to someday maybe cover it out. I don't know, like if we will do another session or
Yeah, let's see, maybe in the future we can do this. So maybe like super high level, what is happening, the create meshes and load models for everyone.
I'm just
for
going
everybody,
to.
including me.
Yeah, I'm sorry, my cat. I just needed to.
Cat made an appearance.
Yeah. You want high level of how it's being rendered?
Yes, not the render frame, but the high level overview of the remaining two functions: create meshes and load models, just to know like what's happening inside, and we'll probably close out.
Yes, very, very important thing is just I will still show it in the code that every mesh that we are providing, and of course also this vertex, this definition struct is also being set up in the pipeline. I didn't show it because it's very important, because when we are starting a pipeline, we are passing the information about our vertices of our mesh, its position, for example, normal if it was provided, the UV if it was provided. But the position of the vertex is, I guess, the most important part, because without that you can't do the transformations, you can't make fragments from that and stuff like that. Yes, so this is important. I didn't cover it. It was bad. Yeah, and it just like I'm now lost a bit. And anyway, you need to have these vertex attributes provided, so we can know where the position is. And when we are creating a mesh, it is basically what happens here. And for the first create mesh function, I'm sorry, my cat.
It's okay.
Yeah, for the first create mesh, it is very simple, because I'm creating a meshes to the sprites. So it is basically two triangles which are making a rectangle for us. Yes, and here I am just defining the vertex positions according to the sprite size of the texture. So it is from 0 to, let's say, 500. And like 500 to 500. And I'm defining these positions. I am updating vertex buffer. I'm updating index buffer if it exists. Index buffer is something that helps us to reduce duplications of the vertices. So if you imagine a rectangle that is basically two triangles, you want to optimize it and not process the same vertex position twice. Yeah, index buffer helps us to do this. Make sense?
Yes.
Okay, great. And yes, this is what happens here. I'm updating this vertex mesh information, and it is stored in the buffer, which is attached to the rendering object. And when we are rendering, we are binding this vertex buffer, which will be sent to the graphics pipeline. Yep. So this is what happened here. And the load models is basically very, very similar, but I am using an external library for that, ASSIMP, and it is doing basically the same way, but it has a bit more complex structure because models which has, for example, several meshes or animation, they stores much more of information that has to be processed. And basically in this class of model, I am trying to handle this. And essentially, I'm just reading from the file with the provided ASSIMP functionality. And then I have a pointer of the information that is stored. And the most important is that the same way as I am doing hard-coded rectangles, we are basically doing same thing here, but without hard coding. I just have all the array of vertices handled by this library. And let's say at the end, I have an array of these vertex positions, which I am calling to my create mesh function, and I am iterating over all vertices. And the same way as with the rectangle, I'm just passing these positions of these vertices from the library that uploaded it for me.
Yeah, super cool.
Yeah,
super nice. Yeah. So this is a lot of the operations. If somebody is interested in building like a game engine from scratch, this is like exactly what you'll need to do. Whatever the technology you're gonna use, like whether it's OpenGL or Vulkan, whether it's like DirectX or whatever, if you want to do this from scratch, like these operations like will need to happen anyway for the loading model and assigning proper positions and vertex attributes.
yeah, I guess. Yeah, that's I guess how it happens here. I hope it was at least like a bit understandable, a bit useful, a bit fun, and a bit interesting.
Let's ask chat. Let's ask
Yeah,
chat. Let's
chat.
do a third and final poll with questions like have you learned anything today? And the answers would be yes, no, and I don't want to talk about it.
Have you learned something new today?
Yeah. I'm really interested if it was really like useful.
No.
For anyone to.
I don't want to talk about it. I don't want to talk about.
We gotta remember to always include this option.
That is very funny. Okay, starting poll.
Okay.
Okay.
So I learned. So like truthfully, I'm gonna press yes.
You gonna what?
So I learned something today. So I'm gonna truthfully press yes.
Okay. Cool. Thank you. Very much people don't want to talk about it.
Yeah. All right.
Okay, then.
It looks like people actually learned something. All right. Thank you so much. You have amazing, amazing body of knowledge. Like, this is so much to take in and to understand. Like, you have to spend a lot of time working on that.
I am. Yeah, but like again, thank you very much for being here and for this stream idea, because I would never find enough of confidence and strength to do such of type of content, and I'm super happy that it happened today, and I'm sure that it will be a very good pointer for me to the future when I will be even smarter and experienced, and I will look and just like, I don't know, this like tear of happiness or something will happen this time. And yeah, again, thank you for being here and for this idea, and it was very
And
cool.
thank you so much for hosting me. This was a lovely experience to me. I learned a lot, actually. So I'm much less scared of Vulkan API now. That's a good thing.
Okay,
Right.
then again, the people. Oh, thank you for being a member for this channel, Furkan. And yeah, then thanks again, guys, for you for being here today and to go with us through this journey. I really hope that you also find it interesting. And I guess then see you next week, probably. Oh no, not next week, but another week, and we will continue again to make a series of engine streaming. Yeah, then thank you,
Great.
Łukasz, again, and